So this is a hyperbola in a linear equation. Okay, so if I were just kind of sketch this graph, it's going to be, it looks like it's trans x, and it looks like it's probably going to be something like that, and something like that. And as a y equals equation, this would be y equals negative, so it's going to be x plus 5 over 4. So it looks like a slope of 1/4, and it's going to look something like that. Okay, so we're going to have looks like two solutions here. Okay, I'm just kind of estimating that, and it looks like this. And again, we probably want to double check this by graphing this. Okay, make sure we can solve this algebraically, but we want to double check this by graphing it. So there's two options here. I solve for y, so I can replace the y here, or we can isolate the x here and replace the x here. I'm gonna try to avoid the fractions. So I'm gonna take equation 1, okay, and I'm gonna make this x equals 4y plus 5. Okay, and then I'm going to substitute into equation 2. Okay, so equation 2 is going to look like this. It's going to be x squared over 36 minus y squared over 9 equals 1. And I'm going to replace the x with 4y plus 5. Okay, so again, I'm using a substitution method. If I can substitute for the variables very easily, that's kind of a nice thing to do. It's often difficult to find an easy way to do addition subtraction. So I want to get rid of these fractions, so I'm going to multiply everything through by 36 first. So I end up with 16y squared plus 40y plus 25 when I do the FOIL there, minus, okay, so if I multiply y squared over 9 by 36, I'm going to get 4y squared. That's equal to 36. So combining my like terms, I'm going to end up with 12y squared plus 40y, and then this becomes minus 11 equals 0. So if I try to factor this, it doesn't look like it'll factor very easily. So it looks like I have, yeah, it doesn't look like it's going to factor very easily. So again, I'm going to need to use my quadratic formula. So my y equals negative 40 plus minus square root of 40 squared minus 4 times a times c. Okay, and that's all over 2a. Okay, so this becomes 1,600 minus negative, so it's going to be plus 4 times 12 times 11. Okay, so I get 2128. Okay, so y is equal to 2128 all over 24. Okay, so divide that by 16. I'm going to get 133. So there's common, looks like there's a perfect square of 16 in here. So simplifying this, I get y equals 40 plus minus 4 root 133 all over 24. Okay, and then this simplifies as common factor 4 involved. So you get y equals 10 plus minus square root 133 over 6. Solving for x. Okay, so I have my x, so x1. So I'm going to plug in the positive value. So I get 4 times 10 plus root 133 over 6 plus 5. So that simplifies to 20 plus 2 root 133 over 3. And I'll do that as 15 over 3. Okay, so that works out to 35 plus 2 root 133 over 3. Okay, so one of my solutions is going to be looks like one of my solutions is going to be x equals 35 plus 2 root 133 all over 3, comma, 10 plus all over 6. Okay, so that's one solution. The other solution would be if I substituted the negative version in there. Okay, so x2 is going to be 4 times 10 minus root 133 over 6 plus 5. So we're going to end up with the same thing except with minus version. So 20 minus root 133, sorry, 2 root 133 over 3 plus 15 over 3. So we get 35 minus 2 root 133 over 3. Okay, so that's the other coordinate. So the other ordered pair would be 35 minus 2 root 133 over 3, comma, 10 minus 133 over 6. Okay, so there it is. There's my ordered pair for where that linear equation would intersect the circle.